Okay, here we go. Here's a roller coaster, some kind of cart, stores 100 joules of energy while sitting still. Okay, so here he goes against that, and then here goes the loop. Okay, and then this is position A. Okay, 100 joules of energy, sitting still, compressed. Okay, position B, thermal energy. Okay, so I'm going to need that. Some kinetic energy, right, because it's going to be moving, okay? I wonder where he is. I think we have a picture. We can see where he is right there, okay? Okay, I'm going to guess that by the second picture, the spring is kind of unwound, right? And now the cart's up here. Okay, you decide on the final state. Okay, so I think the spring is still open, and then I'm going to go ahead and put the cart back down here. That just seems the easiest for the final state. Okay, all right, so let's see what we've got. So I have 100 joules of energy. Okay, so let me go ahead and label this by 20s. 20, 40, 60, 80, 100. 0, 20, 40, 60, 80, 100. And yes, you have to label every graph. I know it's annoying. 80, 100. Okay. All right. So let's see what we've got. So in the first picture, I know there's 100 joules total. Okay. And it's compressed on a spring. So there's going to be EE. All right. It's sitting still. Okay. So no EK. And it looks like to me it's on the ground, so no EG. So we're going to make this the EG equals 0 level at the bottom. Okay, and we're going to just assume, the wheels are touching the ground. That's the ground level. Okay, all right, so if I'm going to do that, that means my entire first picture is going to have to be EE. Okay, so EG, 0 on the ground, EK, 0 because it's not moving, so I've got no whooshies, EE, fully compressed spring, okay, because it's going to like launch it out of there. Okay, all right. Okay, position B is the middle state. There's 10 joules of thermal. Okay, so we're counting the friction. Okay, so now we know we're counting the friction. And it says here too, there is friction. And 50 joules of kinetic. Okay, so like that. Okay, all right. So if I have 50 here and 10 here, I need to add to 100. I know I'm going to have 40 joules of EG. Okay, so that must be the most EG it's going to get at the top of that loop is going to be 40 joules because it's above the ground. Okay, so EG, it's above the ground, so it has EG, the EK. It's probably relatively, I don't know, fast, slow. I'm not really sure. It's moving in some regard. It just kind of told me how much. Okay, it's probably not the fastest though because it's at the top. Right, so it's probably like slow up there as it's kind of making its way around the loop. Okay, and no EE because the spring is not compressed anymore. Okay, so if I have this amount of EK, I need whooshies. Okay, so I'm going to give it kind of like, I don't know, a medium amount. Doesn't even matter because I don't have anything to compare it to yet. So any amount of whooshies is fine, but it should have some because it's moving. Okay, you're trying to show that so I can see if you understand that. Okay. All right. In the final position, you decide. I'm going to decide on the bottom here. Okay. So I'm going to have no EG again because it's at the ground. Okay. EE is nothing because it's not compressed. Okay. Oh, and then E thermal, almost forgot about that. So if I had 20 joules in this picture, it's still going. So maybe I need like 40 joules now. I don't know. I need some amount more. Okay, has increased. So the ETH here is given because of friction. And then by the final picture, it's increased. Okay, so if I've got 20 joules of that, there's nothing elastic. The total is 100. I have to get up to 100. So that means the EK must be 80. 80? No, 60. 60. I can't do math. 60. 60 EK. All right? Okay. All right. So if it's 60 EK, that's a little bit faster than before. Not a lot. Okay. I guess the friction must be eating away a lot of that energy, so it's kind of not usable. Okay. So this is a little bit faster. So I want to make these whooshies a little bit longer. Okay. Don't try to be so exact that like, well, it's real close, so I'll make it like a millimeter longer. I can't see that, okay? Make it longer so I understand that you know that that means faster, okay? This guy is faster. This guy is slower in comparison, okay? So make sure that their wishies match up. It doesn't have to be like proportional. We're not to that level, but I do need to see bigger wishies for faster, okay? So the EK, faster, so it should have longer wishies. Okay. All right. So I'm going to check my checklist. All right. I read the problem. I circled everything. I probably could have circled like these two and this probably. Okay. My background is consistent. I see the same picture. That's good. Okay. My EG levels, ground level is 0. Here again, ground level is 0. So that's good. Some height above the ground has some EG. That's good because there's only one, okay? Kinetic, not moving here, no wishies. 50 joules here, so medium-ish wishies. This one's 60 joules. So then that has longer wishies because that's faster, okay? Elastic here, very compressed, big EE. Okay, these two, the spring is no longer compressed, so they don't have any. Okay, and then thermal, there is friction, so I do have to count it. Never in the first picture. Some amount in the second picture. Oh, they said 10. That's why I was so confused. I'm not redoing this whole thing. 10. Oh, boy. See, I knew it was supposed to be 10. Okay, so 10. I'm not redoing this whole thing. Okay, 10, see, well, okay, my first question, read the problem. No, I guess I didn't. Okay, 10, and then I'm just going to go ahead and leave the rest of that. Okay, that means this one has to be 50. Okay. This is actually a good example because I'm showing you what to do if you end up messing it up. Oh, no, that was right, 50, 40, that was right. I think I just drew it wrong. I wrote it right down here. I see what I did. I wrote it right here. I just drew it wrong. Okay. So see, that's a good example. That's going to show you how to fix it when you go back and double check it because I just know I screwed it up. Okay, 40, 50, 10. Okay, and it'd be good to write these at the top too. Would be helpful. Okay, 60. Okay, then the rest of them are okay. All right, so I probably could have done a little less. You know, thermal, I probably would have made that like 30 and then maybe made my kinetic more, okay? Actually, I might change it because I think I'm going to feel better about that, right? Because I think that's too much. Oh, that's why I was so confused. See, because remember I said 80 because I knew I meant to do 20. Oh, boy. 20 joules, okay, and then this would be 80 joules. That would make sense because it would be more fast. Okay. All right, see, this is good because this is showing you when I go back to double check, do you see I caught some errors that I had? So that was good, okay? All right, so let me go back. Okay, so EE, fine. Thermal went from 10 here. I'm rechecking the problem to 20, okay? So that was right. That was right. I was just inconsistent, okay? So checking your work, very good. All right, let's look at our totals to make sure that we didn't mess up. This is where I probably would have seen it too. Okay, 100 here, 100 here. 40, 50, and 10 is 100. 80 and 20 is 100. Okay, whew, good. Done. Okay. All right, so see, go back through the checklist, check your work, find out if you have any errors like I just did. All right, and then you will hopefully be able to catch those.